Alright, what's up guys? Today I'm going to go over the Unit 6 test review. I'm going to go over some of the problems that I believe are going to be important for you to understand so that you can do well on the test. Now we're going to start off with 6.3, which is graph transformations. That involves knowing how to graph square root and cube root transformations importantly. And also you need to know the domain and range and the starting point or the vertex. Now for this one, we are going to just set it up. I'm not going to finish this problem, but it is important that you understand that this is a square root type function, so that the parent function is going to look something like this. It is half of a parabola. And I'll just set that one up, but I'm going to go over this one more in depth. So this is a cube root type of equation, which means it's going to look quite a bit different. So we have 3 points in the middle like this, and then we have 2 points all the way out there. And this is merely the parent equation. So we get something like this. So I'm going to label that right here, cube root x. But that is not what we're interested in. We're interested in this equation, this one that is transformed. And we need to analyze the features of this function so that we understand how it transformed. So this -1 on the inside is going to correspond to a horizontal shift to the right. Whenever it's minus, it's going to be a shift to the right. This +4 on the outside is going to correspond with a shift upwards. This negative in the front is going to be a reflection over the x-axis. And finally, that 2 in the front is going to be a vertical stretch. It's kind of like saying it's getting twice as big. That 2 is making it twice as big. So applying all of these transformations to this function, we're going to first do the shifts. So it's shifted 1 to the right and 4 up. So 1, then 1, 2, 3, 4. This is the new starting point. Next, we know that it's going to reflect down, and it's going to be stretched by twice as much. So here we see that normally it goes up 1 and then 1 to the right at this point right there. However, instead of going up 1 and then 1 to the right, it's going to go down 2 and then 1 to the right. So it goes in this direction. The reason it goes down 2 is because of that 2 in the front, and it goes down because it's negative. And then from here, instead of going 8 to the right and then 1 up, it's going to go 8 to the right and then 2 down. It's going to be all the way down here. And then we can match up that same pattern on the left side. So it goes up 2 and then 1 to the right. If it's 1 to the left, rather. Then up 2 and then 8 to the left. Or actually 7. After we do all those points, we could connect them like this. And then that is our transformed function. Perfect. So all we have to do is note down the vertex, which is the starting point, which since it shifted 1 to the right and then 4 up, it makes sense that it's going to be right here. 1 and then 4. The domain, well, it goes to the left forever and the right forever. So it's going to be -infinity to +infinity. Finally, the range, it's going to go down forever also and up forever also. It's going to be all real numbers as well. So for cube root functions, it's always going to be all real numbers. The one that isn't going to be all real numbers is the square root function, which is the first example over here. But domain and range has been Unit 1. We've been covering it a lot, so it shouldn't be too big of an issue. Next, we're going to go over 6.4 inverse functions. I'm going to do this example so that we understand what it means to solve for an inverse graphically. Then I'll do one algebraically. So it's asking us to graph this equation and its inverse, meaning we want to plug these x's into our f of x and see what we get for our y. Whatever we get for our y, it's going to help us make a point on the graph. Okay, so we're plugging in 1 minus 3 cubed. This is just an example I'm going to use, but the rest I'm going to do mentally. So 1 minus 3 is negative 2. And negative 2 times negative 2 times negative 2 is going to be negative 8. Now I'm plugging in 2. 2 minus 3 is negative 1. And negative 1 to the third power is negative 1 again. 3 minus 3 is 0. To the third power is 0. 4 minus 3 is 1. 1 times 1 times 1 is 1. Finally, we can continue the pattern with 8 on the other side. 5 minus 3 is 2. To the power of 3 is 8. All of that gives us points right here. So we have this one down here. We have the negative, or the 2, negative 1. We have the 3, 0. The 4, 1. And then the 5, 8. Get a nice smooth curve like this. This is just f of x. Okay, and the way that we find the inverse now is very simple. All we gotta do is flip the x's and the y's. So before, we had 1, 2, 3, 4, 5 as our x's, and now that's going to be our y's. And vice versa, we had negative 8, negative 1, 0, 1, 8 as our f of x's, and now they are gonna be our x's. Same exact thing, we're gonna get these points and we're just gonna plot them all over. And we're going to see what type of shape we get. Okay, looks pretty good. We end up with this shape like this. And it looks pretty good. Has pretty good symmetry about the x, y equals x line. And they seem to match up pretty well. And that's all it's asking for us to do. Just to make a table and graph both the equation and the inverse. Now we're going to do the same thing, but instead of having a nice pretty graph, we're going to do it algebraically. And here we have simple steps for which we can use to solve these types of questions. So step 1 is to replace f of x with y. And that's going to involve rewriting this thing as y equals 3x plus 7 minus 8. Step 2 is going to be to swap x and y. And the way that we swap is going to be very intuitive. It's just going to be those x's and y's switched positions. And finally, we are going to solve for y. That is step 3. The way that we solve for y is we want this thing by itself. So we're going to have to add 8 to both sides so that we cancel out that negative 8 on that side. X plus 8 is equal to 3 cube root of y plus 7. Next step, we want to divide by 3 to cancel out that other 3. And we're going to end up with, x plus 8 divided by 3, which is equal to y plus 7. So now we want to get rid of that cube root. And the opposite of cube root is going to be to cube both sides. That's going to give us x plus 8 divided by 3 cubed equals to y plus 7. The last step, of course, is to get rid of that y plus 7. Or that 7 at the end. So we end up with y equals x plus 8 over 3 cubed minus 7 on the outside. And it's that simple. We just have to use these algebraic manipulations so that we solve for y equals after we swap it. Okay, next. I'm going to solve 2 questions from here so that we understand how to solve square root and cube root equations. Now, whenever we have solve, we're going to look for x. We want an answer of x equals. So the way that we do that is we're going to start by doing 3 steps. So step number 1, actually let me make more space. Oops. Step number 1, we need to isolate the radical. And what that means is we have this radical right here and we want by itself. And now in this case, we do have it by itself. but we might have a times 5 or like a plus 8 in another question, so it's good to make sure we get this step checked for. Step 2 is going to be to cube or square both sides, depending on what type of equation it is. Now, since this is a cube root, we are going to want to cube both sides so that the cube root cancels out. And as a result, we're going to end up with 5x minus 1 is equal to 4 times 4 times 4. It's going to be 64. 4 cubed is 64. And right here, it is as simple as solving for x. Solve for x. And I'll leave myself too much space. Like that. The way that we do that is we have to add the 1. 65. That means x is going to equal to 65 divided by 5, which is going to be 13. So pretty simple, just about taking your time with these arithmetics, but I'm going to make an important note. So since the original equation was a cube root, there are no extraneous solutions. Extraneous solutions. So basically, if we have a 3 in the very front, there are not going to be any extraneous solutions, assuming we did the math right. Now you could still plug it in to see if you got the right answer, but at this point, it's not entirely necessary to check if it's an extraneous solution. Now, when it does matter is when we have a square root. And we're going to look at example 13 for this example. So here we have a square root. There's no 3 right there. So we know that for sure we're going to have to check for extraneous solutions. Now we're going to follow the same steps. Step number 1 is to isolate. So here we have this square root. The way to get it by itself is to add 1 on both sides. And that cancels out the negative 1, which we don't want on the same side. Step 2 is to square both sides. So I'm just going to write square to square both sides. So we square that and we square that. And we're going to end up with something that looks like x plus 7, because that canceled out, is equal to x plus 1 squared. And now from here, we need to solve for x. And it's important to note that this x plus 1 actually needs to be split up like this. X plus 1 squared is the same thing as x plus 1 times x plus 1. And the way we do that is we get this x, and then we FOIL it out so that we can expand it to a form that we understand. So x times x is x squared. Times 1, x times 1 is x, 1 times x is x, 1 times 1 is 1. So all of this to say is we have x plus 7, that didn't change. But the x plus 1 squared, that is rewritten as x squared plus 2x plus 1. Next, we want to move all of these terms in the same side so that we could solve this like a normal quadratic equation. It's going to be x squared plus 1x, so I'll just write x, then minus 6 equals 0. The way that I'm going to do this is by box method, although I encourage you to do grouping. It's not too hard. So first thing you want to do is you want to draw a box like this. So you do x squared and then negative 6. And now we need to think of two numbers that multiply to negative 6, but add up to a positive 1. And if you need to review how to factor quadratic equations, then review those lessons. But in this case, we got 3x and then negative 2x. From here, we have x and x in the first column. We could factor out an x. in the first column and first row, and then in the second column we got a 3 and negative 2 in the second row, giving us x minus 2, x plus 3 equals 0. Now this suggests we have values of x equals 2 and negative 3. Now the last step is we get all of these values that we got for x, and we just have to plug them into the original equation to see if we get what we get. So if we're plugging in 2, that means we put it into the original equation, which is 2 plus 7 minus 1 is equal to 2. So 2 plus 7, that's just 9, minus 1 is equal to 2. That's just 3 minus 1, which is equal to 2, which works out perfectly. There's no problem with that equation at all. Now we're going to plug in negative 3, and we're going to see how that looks. So negative 3 plus 7 minus 1 is equal to negative 3. Now negative 3 plus 7 is 4 minus 1 is equal to negative 3. That's like 2 minus 1 is equal to negative 3, which does not seem to make any sense. This means that negative 3 does not work. Whenever we plug it in, we're not getting the answer that we expect, or the equality that we expect in the equation, meaning that we just have x equals 2 as our answer. And x equals negative 3 is not a solution. It is an extraneous solution. So all in all, keep these points in mind. I'm going to go over these main topics one by one so that you understand my expectations. So step 1 is going to be to know your transformations, to know if H is positive or negative, to know if K is positive or negative, and what that does and how it transforms, and also to be familiar with the shapes of the graph. That is what I expect you guys to know. Also be comfortable with domain and range. It's something that we've handled a lot before. Next thing is to know inverses, so just to understand them conceptually and to know how to do it algebraically. Next, it is important to know how to solve for cube root functions, or cube root equations and square root equations. And we have a process which I listed out right here. And make sure to check for extraneous solutions if it is a square root equation. So for this one, it was a cube root, but this one was a square root, so it was necessary to check, which I did in purple over here. That resulted in one extraneous solution of x equals 2. So hopefully this will help you when studying for the test. This is the questions that I went over does include the content in the test, but it could include more stuff. So just make sure you be comprehensive about your studying.